Hello? Hello? Pritham, unmute yourself.
Yes, sir.
Hello?
Yes, sir, sir.
Please see the, are you able to see the screen?
Yes, sir.
Okay, okay. Okay. Say, this is the new module 2, that is limits, fits, and tolerances. So in this chapter, we are going to study the definition of limits, fits, and tolerances, and the size and the tolerance, and the system of fits, geometrical tolerance, system of tolerance, comparators, classification of comparators, mechanical. So in the classification, you have three types: mechanical, electrical, and pneumatic comparators. So in the first portion of this module is the definition of limits, fits, and tolerances. First, come to the point. What is the limit? What is the limit? See, for this, all of you observe this diagram. What is the meaning of limit?
ಸರ್ ಇನ್ನ ಯಾರು ಜಾಯ್ನ್ ಆಗಿಲ್ಲ ಸರ್, ನಾನು ಒಬ್ಬನೇ ಇರೋದು.
ಹೌದಾ? ಮತ್ತೆ ಹೇಳು, ಬೇಗ ಹೇಳಮ್ಮ.
ಸರ್ ಲಿಂಕ್ ಕಳಿಸಿದ್ದೀನಿ, ನೀವು ಅಕ್ಸೆಪ್ಟ್ ಮಾಡಿ ಸರ್. ನೀವು
ಅಕ್ಸೆಪ್ಟ್ ಮಾಡಿದ್ದೀನಿ, ಎಲ್ಲರದ್ದು ಮಾಡಿದ್ದೀನಿ.
ಹೌದಾ ಸರ್?
ಹಾ, ಯಾರದ್ದು ನಾನು ಬಿಟ್ಟೇ ಇಲ್ಲ.
ಈಗ ಕಳಿಸ್ತಿರ್ತಾರೆ ನೋಡಿ ಸರ್.
ಹಾ, ಬರ್ತಾ ಇದ್ದಾರೆ, ಒಬ್ಬೊಬ್ಬರೇ ಬರ್ತಾ ಇದ್ದಾರೆ. ಪ್ರೀತಮ್, ಜಾಯ್ನ್ ಆದ್ಯಾ?
ಎಸ್ ಸರ್, ಜಾಯ್ನ್ ಆಗ್ತಾರೆ ಈಗೆಲ್ಲ.
ಅಲ್ಲ, ನಿನ್ಗೆ ಕಾಣಿಸ್ತಾ ಇದೆಯಲ್ಲ?
ಎಸ್ ಸರ್, ನನಗೆ ಕಾಣ್ತಿದೆ.
ಹಾ, ಸರಿ ಸರಿ ಸರಿ. ಇನ್ನು 5 ಮಿನಿಟ್ಸ್ ಟೈಮ್ ಕೊಡ್ತೀನಿ, ಎಲ್ಲರೂ ಜಾಯ್ನ್ ಆಗಲಿ ಬೇಗ. Please join. Join first. Okay, shall I start?
ಎಸ್ ಸರ್.
Say, this is the new module, module 2. In this module, you have limits, fits, and tolerances. You have to study definition of limits, fits and tolerances, and afterwards limits of size and tolerance, and system of fits, geometrical tolerances, system of tolerances. After that, second portion of the module contains comparators. For mechanical engineers, comparators are very, very important. This is the measuring instrument, but it compares the dimension. It's not measures the dimension, it's only compares the dimensions of the standard with the component. So in this module, classification of comparators. So in the classification, you have three types of comparators: mechanical, electrical, and pneumatic comparators. Let's come to the point: definition of limits, fits, and tolerances. First, definition of limit. What is the what is limit? What is limit? First, in your mind, what is limit? Suppose if you go to any manufacturing industry for the job purpose, or if you face the interview in the manufacturing industry, first they ask you the dimension of the component. How do you decide limits of the component? Say, suppose in the drawing, if they mention, so what is this symbol? Phi, this is diameter, which indicates diameter. You can write phi starting of the dimension or after the dimension that indicates that is diameter. So phi 40, that is 40 millimeter. If you write the phi before the dimension or after the dimension, that indicates diameter. And you can write the dimensions plus 0.005 and minus 0.05. If you write like this on the dimension, that indicates the negative symbol indicates lower limit. In your lifetime, remember the always, if you write the minus below the dimension, subscript, not power, subscript. If you write the 0.005, whether plus or minus below the dimension in the subscript, then it is called lower limit. Then it is called lower limit. Remember, once again, minus 0.05, if you write like this, or if you write minus 0.05 in the subscript of the dimension, that indicates the lower limit. Lower limit. 40 to the power of plus 0.05. This is the upper limit. This is the upper limit. Then you add the dimension 40 plus 0.05. All of you observe here 40.05. This is the upper dimension. Upper dimension. If you add this to the dimension of 40, then it is called upper limit. Upper limit. Then deduct this value minus 0.05. That is 39.95. This is called lower limit of size. Lower limit of size. And remember, this 40 millimeter or 45 is called basic dimension, basic diameter, or nominal diameter. Remember, basic dimension or basic diameter or nominal diameter. This 40 millimeter is called nominal diameter, basic diameter. And if you write minus 0.05 in the power or in the subscript, it is called lower limit. Lower limit. In the power, if you write whether it is minus or positive plus 0.05, it is called upper limit. If you add these two limits to the nominal dimension or nominal diameter, you will get the dimension 39.95 and 40.05. all of you observe here. If you add the upper limit to the basic dimension, you will get 40.05. And if you deduct lower limit in this dimension, you will get 39.95. Remember, in manufacturing industry, if you are producing the shaft of diameter 40.05 or 39.95, upper limit and the lower limit. If the diameter of the shaft lies between these two dimensions, then accept only two criteria. Only two criteria. Accept or reject. If the dimension of the shaft, that is diameter of the shaft, lies between 39.95 or 40.05, then accept the shaft. Only two criteria. Accept or reject. While turning in the lathe shaft diameter, you cannot produce exactly 40 millimeter. That is impossible. There may be lower, there may be higher diameter. If the higher diameter and the lower diameter, that is within the upper limit and within the lower limit, then accept the shaft. That is nothing but sampling technique. Accept or reject. That is called sampling technique. But is the difference between the upper limit and the lower limit, that is 0.10 in this case, that is called tolerance. That is called tolerance. The tolerance always is positive quantitative number. You can say like this: difference between the upper limit and the lower limit, whether it is negative, it is considered as positive quantitative number. It is considered as positive quantitative number. Once again, if you write the dimensions like this, negative sign, whether in the power or in the subscript, it is called lower limit, and this is plus 0.05 is called upper limit. If you add the upper limit and lower limit, the basic dimension, you will get lower limit and upper limit. The difference between the upper limit and the lower limit is called tolerance. And tolerance is always positive quantitative number. Please, all of you write down module 2. Module 2. All of you please write down module 2. Below that write down limits, fits and tolerances. Below that write down limits, fits and tolerances. First, definition of limit: the maximum and minimum permissible sizes within which the actual size of the component lies are called limits. See, come to this point. See, the difference upper limit and the lower limit is the dimension of the shaft. Upper limit and the lower limit of the dimension of the shaft, upper diameter, lower diameter, in between that, the dimension of the shaft. Next, tolerance. The difference between the upper limit and the lower limit. Say, observe here, 40.05 minus 39.95 is equal to 0.10 millimeter. This is the tolerance. Say, in this example, the diametral difference 40.05 minus 39.95 equal to 0.1. This is the tolerance. Say the limits: upper limit, lower limit. The difference between the upper limit and the lower limit is the tolerance. Please just write down 540 to the power plus 0.05. In the subscript, write down minus 0.05. Like that you write down. Or otherwise you can write like this also. Once again, if you add the size plus 0.05 to the basic diameter of the shaft, then it becomes upper limit. Then you deduct minus 0.05 from the basic or nominal diameter of the shaft, that becomes lower limit. The difference between the upper limit and the lower limit is the tolerance. In the examination, after the class, I will give you the question. Without that question, there is no question paper at all. So after completion of this class, at the end, I will give you a question, important question. Examination point of view, that question is very, very important. Without that question, there is no question paper at all. Next, come to the point, tolerance. Say, the tolerance is the difference between the upper limit and the lower limit. Upper limit and the lower limit. And again, the tolerance is classified into two types. Tolerance is classified into two types. One is upper limit. Tolerance is classified into two types. One is unilateral tolerance. Other one is bilateral tolerance. Unilateral tolerance and bilateral tolerance. Say the unilateral tolerance. Say the unilateral tolerance. The tolerance is classified into two, unilateral tolerance and bilateral tolerance. The limit of dimension, either above or below the nominal dimension, below the nominal diameter, is called unilateral tolerance. For this, good example you have here, diameter of the shaft 525. Say both upper limit and lower limit, both are positive. Remember, both are positive. If you specify like this, then it is called unilateral. Whether it is negative minus 0.10, minus 0.20. If both are in only one side of the nominal dimension, both are in only in one side of the nominal dimension or nominal diameter or basic size. So it is called unilateral tolerance. Say, if you mention plus 0.00, so lower limit 0, only in the upper limit plus 0.018, then it is called unilateral tolerance. So in this case, 0.25, 0.20 and 0.10, both are negative signs. Suppose in the power 0.25 millimeter to the power minus 0.10, that indicates the upper limit, but it has negative sign. Negative sign. Say the specifying the limit in one direction, whether it is positive or negative, it is called unilateral tolerance. It is called unilateral tolerance. Suppose if you mention diameter 25 to the power plus 18 below minus 0.10, instead of writing plus here, If you write minus here, then it is called bilateral tolerance. It is called bilateral tolerance, specifying the limits above below the nominal dimension is called bilateral tolerance. If you specify the limits in only in one direction, plus or minus, then it is called unilateral tolerance. All of you analyze the diagram. Here, this is the component. This is the basic size, lower limit and upper limit. If you specify the limits, both sides, positive and negative, that is upper limit and lower limit, then it is called bilateral tolerance. Suppose if you specify the limit in only one direction, both the powers, both the limits are positive here, it is called unilateral tolerance. Here, both the limits are negative, minus 0.10, minus 0.20. So, specifying the limits like this is called unilateral tolerance. If you specify the limits positive and negative, lower limit and upper limit, then it is called bilateral tolerance. You can analyze the unilateral tolerance and bilateral tolerance. Say specifying, say this 0 indicates 40 diameter. This is 40 diameter. If you specify the limits, upper limit and lower limit like this, that is called bilateral tolerance. This is called bilateral tolerance. If you specify the limit positive, both the limits in positive direction, both the limits in negative direction, that is called unilateral tolerance. That you can understand the diameter of the shaft is 40. That is called zero line or basic size. Zero line or basic size. Zero line or basic size. If the limits above this zero line, above the zero line, if you specify only in the positive direction, see above the zero line, always positive, below the zero line, always negative. This is the block with the hatched lines indicate the unilateral tolerance and bilateral tolerance. In the bilateral tolerance, some of the dimensions are above the zero line, some of the dimensions are below the zero line, that is negative as well as positive values. That is called bilateral tolerance. Bilateral tolerance. Suppose the dimension above the zero line, that is positive, below the zero line, negative, that is called unilateral tolerance. Say the tolerance is classified into two types. One is unilateral tolerance and the other one is bilateral tolerance. So if you write plus 0.18 above the 25 millimeter diameter, right below 0, that is called unilateral tolerance. So, or you can write plus 0.18 plus 0.10, both are in one direction, positive direction, then it is called unilateral tolerance. And here, this is bilateral tolerance. That is, the nominal diameter is 40, the lower limit is minus 0.05, upper limit is plus 0.05. This is bilateral tolerance and this is unilateral tolerance. You can analyze the unilateral and bilateral tolerance by using this diagram. Next, come to the point. This is the component produced using lathe. Say you have three portions in this component. This is step turning or shoulder turning using lathe. You can consider the dimension L1 to the power plus A minus B, that is bilateral tolerance, upper limit plus A, lower limit minus B. If you add plus A minus B to the dimension L1, that becomes the base, that becomes the lower limit and upper limit of the dimension. Then the L2, dimension L2, that is the limits, upper limit plus C, lower limit minus D, add to the diameter L2, you will get the dimension. Next, come to the point. First one, L3, the upper limit plus E, lower limit minus F. Then add all the upper limits of L1, L2, L3 becomes L. Then add plus A plus C plus E. Then deduct the values minus B, minus B, minus D, and minus F from the basic dimension. You will get the L. This is called accumulation of tolerance. Accumulation of tolerance or tolerance accumulation. Say, suppose if you are appointed as a shift engineer in any machine shop, first you have to study the upper limit, lower limit of the dimension. That is nothing but in the drawing itself, the customer clearly mentioned the upper limit and the lower limit. If the component which not meet the upper limit and the lower limit of the dimension, then customer outrightly reject the component. So that is very, very important. That is very, very important. You see that in the lathe or in the milling machine or in the CNC turning center or in the any CNC or special machine tool, see that the component is produced within the limits. Within the limits. Otherwise, you have to reject in the machine shop itself or in after sending to the customer. There the customer again he conduct the checking of the dimension, conduct the inspection, then he reject. Then there may be loss of amount due to transportation of the component from your company to the customer. So for that reason, the limits, fits, tolerances are very, very important. Very, very important. Limits, fits, and tolerances are very, very important. Next class, we discuss about fits. Today's class only understand upper limit and lower limit. Please, all of you, write your name and USN in the chat box. Please, all of you, write your name and USN in the chat box. And I hope all of you received the message for first test. All of you received the message for first test. So as per the instruction from the principal, you have 1.5 module portions for the first test. So up to 17th of this month, whichever the portion I will cover, that will be the portion for the first test. Remember, 17th of this month up to 17th of this month, October, whichever the portion I cover, that will be the portion for the first test. So according to the instruction from the principal and department, You have 1.5 module portions for the first test. Please, all of you write down the question. Explain briefly. Explain briefly limits and tolerances. Explain briefly limits and tolerances with suitable suitable example. With suitable example. Mark it. This is very, very important. Almost all the question paper, you have this question for 5 marks. Mark it. Very, very important. I repeat, explain briefly limits and tolerances. Limits and tolerances with suitable examples. With suitable examples. Mark it. This is very, very important. You can expect this question this time. This question carries 5 marks. This question carries 5 marks. Next, come to the point. Please, all of you write down the dimension. You write rough diameter, rough sketch of shaft, rough sketch of shaft, and write down 40 millimeter or 5 millimeter or 5. 40 to the power plus 0.05, 40 to the power plus 0.5 plus 0.05. In the subscript, write down minus, subscript write down minus 0.05. Minus 0.05. If you write like this, that indicates the upper limit and the lower limit of the nominal diameter 40. Or even you can write this also, 540 to the power plus 0.05, below that write down minus 0.05. If you write like this, that is also correct. As you already, you have 40 to the power plus 0.05 in the subscript minus 0.05. If you write like that also, both are correct. Write the rough sketch of shaft and indicate diameter 40, that is 5. Then you write down tolerance equal to, write down this dimension. Tolerance equal to upper limit minus lower limit. Tolerance equal to upper limit of size, minus lower limit of size, equal to 40.05 minus 39.95 equal to 0.10 millimeter. 0.10. Once again, I repeat, tolerance equal to upper limit of size minus lower limit of size equal to 40.05 minus 39.95 equal to 0.1 millimeter. 0.1 millimeter. Okay. Next, below that write down in inverted commas, in inverted commas write down. Tolerance is, write down in inverted comma, tolerance is always a positive, always a positive, tolerance is always a positive, quantitative, quantitative number. I repeat, tolerance is always a positive quantitative number. Close the inverted comma, put a full stop, underline the sentence. Tolerance is always a positive quantitative number. Positive quantitative number. Next, come to the point. Write down unilateral tolerance. Unilateral tolerance. Write down like this. 525 to the power plus 0.18 plus 0.18. Below that write down plus 0.1. In the subscript write down plus 0.1. The mentioning of plus and minus is very, very important. Write down unilateral tolerance. Write down the dimension 525 to the power plus 0.18. In the subscript plus 0.1. In the same way, write down one more example. 525 in the power minus 0.1 in the subscript minus 0.2. Minus 0.2. If you specify the dimension upper limit in one upper limit or lower limit in only one direction, that is called unilateral tolerance. Next, write down bilateral tolerance. Bilateral tolerance. For this, write down like this. 540 to the power plus 0.05. In the subscript, write down minus 0.05. This is called bilateral tolerance. Bilateral tolerance. This much is enough for you for this class. And now unmute yourself